in the following exercise, we need to rewrite the vector additions into just one single vector. I know it looks complicated, but it's not like that, so do not worry. So for the first one, we can see that it's vector AE, so it's traveling a vector that's traveling from A to E, and plus it's from E to D. So A to E, E to D, it's sort of like a vector moving from A to D. So this will be AD. Does that make sense? So again, A to E plus E to D is equivalent to A to D. So if we want to do a shortcut on this, we can actually cut off the same alphabets. Like for example, if we have A to E plus E to D, this only works when it's a plus. We can actually cancel the E. So this will become a vector that's from A to D. So if we apply the same shortcut to the next one, we can actually cancel off the A's because they are near to each other and they are of the same alphabet, and also E. So it will become just a vector that's starting from B and ending at D. So we can write this as B to D. So that's the single vector that represents the whole thing here. So if we double check this on the diagram here, so it's a vector that's moving from B to A this way, and A to E this way, and then E to D this way. It's sort of moving from here to here, here to here, and here to here, which is like this. So this will be the resultant vector that's BD. So if we do the same shortcut for the third one, it will be just cancelling the same alphabets. It only happens when they are like next to each other, and cancelling this. So we will get CA. So if you trace it in this diagram, that will work too. And what if I have something that's negative, like a negative vector? So just now when we were learning, previously when we were learning negative vectors, we know that a vector that's C to D, it's a vector that's going here. But when you put a negative, it sort of switches the direction into like an opposite direction. So this is a vector CD, and this is a vector that's negative CD. So we know that a vector that's a negative CD is also the same as the vector DC. So this means that if we want to get rid of the negative, we can just flip the D and the C around. So in this case, we can put D to C here, and we'll just copy this one. And this happens the same as well. In order to change this to positive, okay, we flip this around. So the purpose of swapping this around to make it positive, it's so that it's easier for us to trace and it's easier for us to simplify. And as you can see, if we use the method, the previous methods, we can cancel C and we can cancel B, and this will result in a resultant vector that's DA. So we have so far simplified 4 of this vector into single vectors. The next thing that we are doing is we need to illustrate the vector in a line, and we have to construct vectors based on like certain equations. So let's say I have 3 vectors. I have vector A, and I have vector B that's going maybe this way, and I have another vector that's C. So vector C is going here. So if I'm asked to construct let's say B plus C, how do I construct this vector? So if I need to do B plus C, I need to start from vector B, so which is this one. So I'll just copy this onto a space here. So it will be sort of like this line with the same direction. So it's a line that goes from here and it ends here. And we call this vector B. And if we want to add another vector C, from the ending point here, we draw another vector that's C, like that. So this will be my vector B plus C. What if I want to draw a vector that's A plus B plus C? So we know that B plus C goes like that already. It doesn't matter which we add first, because we will end up with the same resultant vector. But let's say I want to add my A at before my B. So this goes right in front here. So I will get a vector A like that. So and A, B, and C will have a resultant vector that goes this way. So this is my resultant vector of A plus B plus C. What if I have vectors that subtract? For example, what if I have A takes C? I can start with drawing my A vector A first. So this is just here. Vector C will be negative, so it means that instead of going upwards, I'm going to draw a vector that sort of like it's parallel to this with the same length, but at the opposite direction. So I'm looking at drawing a vector here, like this, here. So this will be my vector C, take C. So A take C is equivalent to A plus negative C. So the resultant vector will be a vector that's here. So this will be A takes C. What if I have another, I have to draw another equation that's maybe A take B take C. So starting with A, because this is a positive A vector, I will just copy from here. This will be A. B is a vector that goes sort of to the left. So that's positive B. In order to draw a negative B, it will be a vector that is of the same length, but to the right. So it will be sort of same length to the right. This is a negative B. And a negative C will be a vector that's going down, but parallel to this one. So it's sort of like this, negative C. So my resultant vector will be a line here that's A take B take C. And now if we remember the scalar multiplication that we learned previously, do you remember that like for example a simple vector like vector B, if we double the length, it will become a vector 2b. And if we shorten the length into half, it will become half b. And if we switch the direction, it will become a negative. So how do we draw a vector that's maybe 2a plus maybe half b? So in order to draw this one, we know that we have a vector a, but 2a is sort of double the length of this vector. So let me just transfer this here. So it's sort of like this, but double the length. So this is 2a. And then I need to draw a half b. So we know that a vector b is this one. So half b will be sort of the same vector with the same direction, but half the length. So it will be a shorter one. So that's half b. This is 2, half b. So the resultant vector will be a vector that goes from here to here. So this vector will be called 2a plus half b. So how do we draw, let's say, how do we draw a vector that's negative 3 over 2c? We know that C is a vector that sort of goes up this way, and negative 3 over 2 is sort of like negative 1.5 C. So we know that the length of the vector is 1.5 times of the original one, and it's in the opposite direction. So if we draw this over here, this will be like, this is the same length, 1.5, and therefore the vector will be 1.5 times of the length of the original vector and opposite in direction. And what if we have another question? For example, half A, take 1 over 3B plus 1 over 4C. As we know, a vector A is in this direction and it has this sort of length, but when we halve it, it's still positive, so it's still the same direction, but the length will be halved. So this would be half A, and 1 over 3B will be, if we look at vector B, 1 over 3 is sort of like 1/3 of the current length, and because this is negative, we will actually switch the direction. So the 1 over 3B will sort of go to the right, but 1/3 of the length. And C, if we look at C, 1/4 of C will be just really short. So it's a vector that's really short. So this will be 1/4 of C. And the other one is negative 1 over 3B. So you will see that the resultant vector, because it starts from here and it ends here, the resultant vector will sort of look like from here to here.